We present a new approach for generating user-centered flying creature animation paths for outdoor augmented reality experiences. Taking a short sequence of storyline actions as input, our approach finds an optimal character animation path in the real world, considering the user's viewpoint and surroundings. Our approach involves two main steps: location compatibility prediction and waypoints and path synthesis. First, the location compatibility prediction model determines suitable locations for character storyline actions in the 3D scene. Our learning-based prediction model takes location images as input, then predicts the probabilities of compatibility between specific locations and a range of storyline actions, such as drink, eat, sit, sleep, and swim. Our location compatibility prediction model goes through two phases of training. In the environmental feature extraction stage, we utilize a pre-trained feature extractor to compute the mean environmental feature. This mean feature vector is used to initialize the weight of our predictor. In the fine-tuning stage, we update both the feature extractor and the fully connected predictor. This allows us to refine and optimize the model further based on the specific requirements of our dataset. After these two stages, our model predicts the compatibility value as the final output. Here are the location compatibility maps for different storyline action classes. They show how compatible different locations are for drink, eat, sit, sleep, and swim. As observed, the drink action is compatible with locations around the lakeshore, and the swim action is mainly concentrated on the water. Next, taking the 3D scene, location compatibility maps, and storyline actions as input, our approach generates waypoints and a corresponding path for character animation. Our approach aims to find a user-centered flying creature animation path. It samples waypoints among voxels, where the character performs storyline actions. By using a modified A-star algorithm, we find an optimal path for character animation in augmented reality. This path takes into account visibility, distance from the user, and path smoothness. First, our approach determines which voxels are visible in 3D based on the user's current position and head orientation. To do this, it applies two culling processes: frustum culling and occlusion culling. The blue area in the right image is found visible by the culling processes. Therefore, our approach prefers to sample way. To generate a user-centered result, our approach uses a distance term to keep the generated path close to the user. Our approach would choose the closer voxels as possible. Our approach also uses a smoothness cost to steer the A-start algorithm to generate a smooth path as possible, to avoid paths with sharp corners. During the optimization process, the waypoints are updated. Subsequently, our modified A-star algorithm computes the optimal path that corresponds to the waypoints. Please refer to our paper for more details on the optimization process. We demonstrate results in real-world campus. We show the location adaptiveness of our approach by adapting Story A to Location 1 and 2, and we show the generation capability at a location by delivering Story A and Story B at Location 3. The results show that our approach placed the waypoints and the path reasonably. First, our approach generates character animation that is fully visible to the user. As the simulation at the user's position shows, the path is clearly observed by the user. Second, our results show that the waypoints are reasonably chosen as their associated storyline actions are compatible with the scene contexts. For example, the dragon swims in the lake or the virtual fountain, which is consistent with the location compatibility map predicted by our learning model. Our approach considers the 3D layout of the scene, and the user is not restricted to standing on the ground. This result is generated for a user looking outside the window from a building. We conducted changing viewpoints experiment on the campus location. Our system can update the path considering the current user's viewpoint in real time. We conducted a user study to evaluate character animation synthesized by our approach in augmented reality. The user study results show that our approach selects waypoints compatible with the scene context for performing storyline actions. It also generates a user-centered path, considering the user's perspective. Thank you for watching.